Welcome to the Writing Glitch. Today we're going to listen in as Teresa Roderiques explores week 2 of a book study that she did on Handwriting Brain-Body Disconnect.
In the book per type of dysgraphia, primarily because I'd like to use it in my evals also, but also I didn't want to mix up any of the information and get it in the wrong spot if I was doing it myself. And I was like, no, if this isn't something you're thinking about doing, I'll just use it I'll create one as a checklist or whatever. So I had to hear that question.
Open it up and tell me what you think.
She didn't make it complex. It's not really.
Hey, forgive me. Yeah, forgive me. I can't remember your principal's name.
Lauren.
Lauren. Tell her I said hi.
I will. I'm headed over to the school today. Now, did you send it to my email?
No, it's in the chat.
Is it in the chat? Okay, here. Oh, here we go. It did. I don't know why my chat didn't pop up. Well. Oh gosh, this computer is like from 2015. It's going to make me have to download it and go into
You know what? Hang on a second. Let me, Sherry, you can share your screen and share it, right?
Yeah.
Oh, so bad. I'm sorry, y'all.
No, it's okay because
look at this. Oh, that's beautiful.
Isn't it cool? It's really basic, but at least you can have something that is like easy for parents to read as well.
Yes. Yes. Actually, what I like the most is that it started with strengths and then it went to the weaknesses. Sadly, I think as a therapist, sometimes you only think in the weaknesses and where you need to start.
Mm-hmm.
You don't always come out as your first thought being the strengths. I love that. This is perfect.
Thank you. Paula, yes. Were you able to open it? Okay.
Yeah, it looks great.
So I'm going to even start before Teresa gets into the lesson today. What I've discovered, the more and more I delve into the dysgraphia, is if you look at that weakness list for the motor, take away a comorbid condition and visual, spatial, and memory are big problems with the dysgraphia. Anybody that has this other neurological condition, all of the stuff under motor is like there, whether it's dysgraphia or not. The other condition supersedes it. So that's why at the very bottom, like any other comorbid condition, that is really what I'm finding with motor is there's always a comorbid neurological condition that's going with it, which is I also contributing to the crossing midline, bilateral integration, and all that stuff.
And I feel like a lot of them tend to come up and fall into that. Oh gosh, see, now that I open my mouth, I've got my words backed up. Discoordination. Oh, I'm gonna have to look it up before I say it wrong.
Developmental coordination
disorder.
Disorder. DCD. DCD.
Yeah, thank you.
See, that's become the buzzword lately. That's become the new buzzword lately, especially in the schools, because that doesn't go away.
It's just in my growing up life, they were praxic. I do think, and a lot of times, I don't think that parents kind of realize that this is there or that. And again,
they're trying to classify a kid who's clumsy, who's got all these neurological things. So they may have attention, they may have coordinate, they may have a group of things. So they're collapsing them into this developmental coordination disorder because it doesn't go away, and we have to support them along their journey, kind of thing. So that's what they're classifying these kids at.
Yeah, and the term developmental coordination disorder originated in Europe and has now migrated over here.
Yeah.
Oh, okay. Okay. I do think there's some underlying reflex, retained reflex.
I have stuff for you too. I have article.
Yeah.
So we are talking, poor Paula's feeling like she's out in the field. Did you understand any of this conversation?
A little bit.
Okay. No, it's fine.
Yeah, so my background is I'm a dyslexia therapist. So little different from the OT world, but I did get to read up to chapter 7 last night, so I feel
Whoa.
not too, yeah. I'm just listening for now and
Okay.
writing some things down and like, look,
That's good, because that's where we're gonna be at today. We're gonna,
Perfect.
and I'm sure the brain really, because if you talk to an OT, we've been there, done that a bazillion times. So
Yeah.
you have to do the brain, but
Yep.
Cheri's book, to me, after going through this so much, has been the best way, and going through her course has been the best way to get this brain area thing settled. So I know you've read it, but once you've gone through it and then reread it again, then you're gonna go, aha.
Mhm.
And then I was just working on something, and hopefully by next week, once I put it together or whatever, it'll make even more sense, because
Yeah.
I think that's the big, it's where do these things occur? And then you'll see there's a connection there, because
Right.
it's hard to see it. It really is.
And we deal so much with that with the reading piece, but I really liked reading it and then how you connected it back to how that applies specifically to handwriting. It was like, oh, we're talking about the
Right.
driving example. And so, yeah, I already felt, hey, this is like the best explanation of all the pieces of the brain that I've read
Yeah.
before, where it usually feels really overwhelming. So,
Yes, see, I've told it many times.
yep.
All right,
So I'm
well,
gonna sit back and let Teresa take over and do a summary. Without further ado, Teresa, go for it.
I'm going to, let's do this. I'm going to share my screen, and I'm going to share book study 1. All right, so this is purely from the text. And so I took this, and you'll all get this, so don't worry about it. So because we're talking about the central nervous system, it includes the brain and the spinal cord, and then the nerves that leave the spinal cord. So the brainstem, that's where all that autonomic responses occur. The part of the brain, now that's that oldest part of the brain, and it controls parts of that automatically excite and calm the bodily reactions, okay? So the autonomic nervous system is where that's occurring. The breathing, the body temperature, and the heartbeat. So the brainstem is, they even call it reptilian because it's the oldest and where everything occurs. And one of the points that it was made in the book is that it can be overridden by other parts of the brain. Okay? Plain and simple. I really wanted to make sure that you guys knew that it was very easy. And where's my, oh, there it is. Cursor. Okay, the cerebellum.
Before you move on
Go ahead.
from the autonomic,
Yes.
there's a term that we as OTs hear. For Paula, you probably never heard this word. Interoception. I'm going to put it in the chat.
Oh, perfect.
So the autonomic nervous system and interoception are like, they're all integrated together.
And this is the new buzzword too.
So, and as soon as you started talking, my brain went back to the day that I was writing that section of the book. I can tell you exactly where I was when I was writing the section on autonomic nervous system. Would you like to know where that was?
Sure.
I do. Where were you?
I was at Wegmans in their section of the restaurant or the supermarket. It's one of those supermarkets that has a section that you can eat on the side. So they have a big takeout section, and you go buy your food and then you can go sit and eat. And one of my children was at school. My kids went to school an hour from home, and they didn't go every day. They were mostly cybered before cyber was a cyber. And so my daughter had to actually go into the building that day, and I wasn't allowed to stay at the building during the event. So I went over to Wegmans. I don't know. It just hit me like crazy. And I know it's a really bizarre side note, but when you start to do this, it becomes ingrained. And so thank you, Teresa, for that memory moment. But when you're thinking about the autonomic nervous system and you hear the word interoception, think about that whole nervous system being really intertwined together.
Yeah, it's that gut instinct that tells you, I need to go to the bathroom, I need to do this. It's automatic and it's almost things you can't control. And it's if you ever have that gut feeling, like something worries you, that's where, and that Cheri we've gone into that a lot more recently, but it's also those things that the kids don't understand as much as you think they should. And that's when those kids get more worrisome and when things like that occur. If ever you have a kid, like I had a child at school who had bathroom issues, that's part and parcel of sometimes why they don't excel or do things in school because of that. And it gets to be an issue sometimes. The interoception takes over their lives. And it's hard to believe that's something that occurs, but it does until they really understand how to handle that. So the cerebellum is part of the brainstem. It's the largest organ. Now, girls, as I'm doing this, if you follow along in your book, I'm going verbatim. So if you want to follow along, the pictures are in the book as you go along. It's the largest organ and it's the refinement center. And it makes meaning out of the movements we do and it smooths it out. So it's refining everything. So if you thought the brainstem was the beginning and then it filters through and it refines everything, it makes it smoother. I took the point in saying children with dysgraphia have difficulty with smooth lines when writing. They tend to be jerky and their marks and the result is frustration and refusal to write. We see this all the time. And these movements may be the result of cerebellar pathway dysfunction. So way back, it's not even that it came to the cortex and to the frontal lobes. It's way back where you got to get back to the roots of where this child is having difficulty. So the limbic system, as you move forward into the brain, from the brainstem, the next section is the limbic system, and that's the center of the brain, and it controls our emotions, short-term memory, and codes our movements into files. I love that Cheri's got this down. She talks about the filing system. Each movement becomes associated with our emotions. That's where that movie comes into play, where here's the filing cabinet. And so whatever, like we talk about how a kid, if they're writing and they just pretend it's on fish and they can't get that down. So anytime you bring forth this, let's write about fish, they're going to be like, I don't ever want to talk about fish again. I'm not writing, blah, blah, blah. So you've put a bad memory with the writing and they will never, ever want to write about fish because that's the bad memory and they couldn't write it. So they'll never, ever want to write about fish again. I know it seems weird, but you've put a memory with an emotion and forget it. They will never do it. In this case, it's, if they were proficient at hitting that baseball, you gave them an awesome memory and they'll love it forever and they'll be so proud of it. Every time they go up, they want to hit that baseball. But if it was a bad memory, then they'll think of themselves as a failure and they won't want to do it. It's tying an emotion and a memory together. That's what the limbic system's doing in our brain. They're calling it the emotional heart. It's either tying a good memory or a bad memory to an emotion. The amygdala is the center of fear. The brainstem responds in the fight, flight, fright response. It's located just above the brainstem in the center of the brain, and it relays messages down to the brainstem, but also to the hippocampus and other parts of the brain, and it helps the autonomic nervous system, and it can release cortisol in situations of excitement. So the hippocampus, that's your short-term memory center. And it has a, go ahead, Cheri.
Are you following, Paula? Are you doing okay? All right.
Okay. I know I'm going fast, but what happened is we're just following the brain from the back into the center, and then we'll be going to the sides.
Yep, all good.
Yeah, you're going to get all this. It's in a Word doc, so once we're done, it'll be there for you guys to download. And
No
I
problem,
I just shortened everything that Cheri had in the book. So there's a right and left portion, and all good and bad memories flow through this location. And again, it links our memories to an emotion that are generated in the amygdala, and it takes what's happening throughout the day and stores it. And this is a quick access file, is our working memory. So like it keeps our daily memories in segmented files by time until we sleep. This is why sleep is so important. So during sleep, the memories in the hippocampus are filed in the long-term memory center and before it gets moved to the thalamus. And then when you sleep, the short-term memories are converted to long-term memories. So people that have trouble sleeping may never get to a REM sleep and therefore never move their daily memories to the long-term memory bank. So that's pretty sad. So if something occurred and you're like, oh, do you remember that? And it may not have gone where it's supposed to, so that those people never get to that point of it storing. Maybe it'll store eventually, but if they don't have that good sleep, these kids may never get to that point of putting stuff in long-term memory. You may see this, even Paula too, with those kids who are not getting those, you taught them something, it's not storing. Check with their sleep, check with the parents. That's something that Cheri, there was times when there was those things. Not only like Paula, we were talking last time about reflexes. You ask the parent, like when we had the kindergartens coming in for intakes, how would their sleep? It might be those strange things that you talk to somebody about and the parents, what do you mean sleep? I'll be at an IEP meeting. How is their sleep? And the parent would be like, oh my God, they're horrible sleepers. How many times do we find we're sitting at an IEP meeting and the parent says the kid takes melatonin? Automatically, their sleep is poor. So if you think back and their memory issues or the fact that you have to keep repeating a lesson to them, that means that they're not getting it. And that's why you have to support what they're learning with like cues or prompts all the time. So that may be something to focus on so that they'll get that into the long-term memory. It's so important. It happens with us, so it happens with the kids just as well. So the thalamus resides on the top of the brainstem and it connects the brainstem and the limbic system, and it is the gatekeeper of the limbic system. It filters the sensory system from all peripheral sensory systems. It is the major role of the thalamus to control whether the person is awake or asleep. And second, it filters visual stimulus to the occipital lobes. And third, it regulates auditory information that is sent to the auditory cortex. So the thalamus is pretty important. Finally, it coordinates motor control, coordination, and modulates the intensity of movement and motor planning. So if a kid really is all messed up, this may be what's going on. Information is sent to many areas of the cerebellum and cortex. This information allows the brain to associate individual pieces of information with other pieces of data into a message that is sent to the basal ganglia. The thalamus is going to be a wicked important, being that it's a gatekeeper, but it has so many functions right now that it's one of those areas that is critical in our brain function. Can you imagine brain injuries right now? All you can think about is kids who are hitting their heads and what is occurring. So the basal ganglia is a group of tissue masses near the hippocampus that takes movement patterns and supports the hippocampus and the amygdala to convert movement from short-term memory and move them to long-term memory. And the basal ganglia tells us what to do with the information that is processed. It converts the cognitive information from the cortex, refined movements from the cerebellum, and emotional and memory connections of the limbic system and relays it to the body. The neural pathways do all the communication in a millisecond. When it does not work smoothly, reactions like tremors or jerky behaviors. So the basal ganglia will be that area that converts the information. But I've had a child who has, in some cases, the jerky behavior, and it's not CP, and it's definitely not a condition. So we really couldn't tell what it was. So it definitely could have been from the basal ganglia that the information wasn't processing well enough for her to stop those. It was like almost intention tremors, but it was unknown etiology for her to do that.
So
She was definitely.
I want to pause and I want to ask a
Yep.
question about the
Go
basal
right ahead.
ganglia. Beth, did you learn a whole lot about the basal ganglia in college?
Not in school. It was all information that I went back and learned on my own. Sensory integration was my beginning. And so I learned a lot there. But now it was never really, even when you're learning it that way. It was never tied to outward motor coordination. It was more tied to, back then, 20 years ago, 15 years ago, it was more tied to the sensory inhibition and self-control and more of that, and the integration of all of our sensory systems, more than tied to movement responses that you see outwardly, that we would notice, that our clinical reasoning would go to.
And Teresa, would you concur on that as well?
Yeah, I agree. I've told Cheri should know more than anything that as soon as you read through this, it made more sense because it didn't before. It was just parts of the brain before. It didn't make enough sense to connect one piece to the next piece.
So when I was doing the research on the basal ganglia and trying to find out what was new about it, I had learned some of this stuff. So I went back to my books from school. Now, I was in school 32 years ago, okay? And somewhat before that too, because A&P was even before that, because I have another degree as well. The amount of information that the neuroanatomy textbook had was 2 sentences.
Mm-hmm.
That sounds right. Like, I don't really,
Yeah.
in my, we just didn't, it was terminology more than function.
Yes, I agree.
They know so much more today than they did. Now, I had to extrapolate a lot of information because they're doing much more research in the basal ganglia on adults. And they're finding that the basal ganglia and Parkinson's that's where the issues are coming from with Parkinson's disease. But there's also some other similar diseases that are really being, the origination is the integration of from the basal ganglia down to the motor function. So I wanted to pause there and really take that moment for you to have that realization that, yeah, we didn't learn much in school. Paula, I want you to also hear that we even as occupational therapists did not learn enough about the basal ganglia in school because they didn't know.
Yeah.
But like you said, Cheri, like my student, I did do the same thing. I did the research on her, and she had unknown etiology for why she was having the jerkiness and the tremors, and why you knew she had intention tremors. I even gave her a weighted mitt and weighted cuffs on her wrists. But why was she having it? She didn't have no anoxia when she was born, none of those classic symptoms that you would have seen, but could it have been the basal ganglia? Who knows? There wasn't a lot of research, like you said, done. But it could very well have been something going on there to give her these issues because no one looked into it.
Yeah. The other new research that is out is about the cerebellum. And so if we back up to the biggest part of the brain down under the occipital lobe, the cerebellum, what they're finding is there is a direct link to learning. So the more jerky a kid is, the less likely they are to learn. And with trauma, the cerebellum shuts down. Mm-hmm. It doesn't work. And so there's this disconnect between learning and trauma because of the cerebellar shutdown. So why it's shutting down, it's a protective mechanism. But other than that, they aren't quite sure. But a lot of the new therapies that are out there are stimulating the growth and the reactivation of the cerebellum, which is re-engaging kids in learning. I don't know if you knew that, Beth.
It makes a lot of sense. It does. Because look where the cerebellum assists the hippocampus and the basal ganglia and the limbic system. Okay, so it does connect so many systems that it should be the one that needs to be looked at. Okay, so we're heading down to, we did basal ganglia, and now the cortex, neocortex or cerebrum is the control center. This part of the brain is what sets humanity apart from other species. It's also the most refined part of the brain. and it is where conscious thought comes from. The cortex can override, so that's what I had mentioned before, overrides the lower parts of the brain if we think it through. The cortex is separated into different lobes, and each have a right and left side. The lobes are called the occipital, the temporal, the parietal, and the frontal lobes. And the cortex takes over control of the brainstem to alter your breathing patterns. The cortex relays messages to the basal ganglia and down through the brainstem to the body. The brainstem breathing takes back control when you are not thinking about your breathing patterns. It's funny that it says that because I had an MRI on Monday, and she's, okay, shallow breathing, and you have to think about how to do that. And so obviously it was my cortex that was telling me to breathe more shallow, because otherwise you automatically breathe and you just don't think about it. But when you have to think about it, your cortex definitely takes control and is in charge of what your breathing is. And the next one, the occipital lobes, takes what we see in our retina and converts it to color forms and determines the motion of an object that we see. It is in the occipital lobes that form, shape, and the direction of the motion are detected. The information received by the retina is upside down and travels the optic nerve to dispense images from both eyes into the occipital lobes. This information is shared with other areas of the brain and interpreted. 50% of your brain is dedicated to vision. The nerves that travel from the retina to the occipital lobes pass through the limbic system before arriving in the occipital lobes. Each object we see is documented in our brain with an emotion and short-term memory. After interpretation, what we saw gets converted into long-term memory while we sleep. Each vision is interpreted for the emotions attached with it and is stored in the hippocampus. So this almost brings back everything we just talked about, where the traveling of the image is going to. It is the occipital lobes that originally analyze all the colors, forms, and movements associated with the memory. So it ends up interpreting it. The occipital lobes only create digital code for what is seen. The other lobes do the interpretation. So it doesn't necessarily do anything more than that. The interpretation of color, forms, and shapes are registered in the occipital lobes, are sent to the temporal and parietal lobes. Movements are sent to be interpreted in the cerebellum, prefrontal cortex, and basal ganglia. Wow. It's the whole brain that needs to do this. So we only suck it in from one spot, but then there's other spots that are going to take over. So the temporal lobes to the sides of the brain, behind your ears, are after we sleep and move through the sleep cycles, the memories move to the temporal lobes. Temporal lobes are where long-term memory is stored. They also contain the centers necessary to translate what we hear. Our ears take the sound waves of our environment and change them into digital patterns. These patterns move to portions of the temporal lobes that take what we hear and receive it. These areas are called Wernicke's areas, known for receptive language. From this area, the messages are sent to the limbic system and other parts of the cortex for interpretation. The messages bounce back to the temporal lobes to the Broca's area, expressive language, before taking the last trip through the basal ganglia down through the brainstem to make movement. After being interpreted in Broca's area, oral language and written language are further processed in different areas of the brain. This results in different types of expressive language. Because of these areas, different neural pathways, oral or written language-based difficulties could occur. These include oral dyspraxia or dysgraphia, respectfully. So there's where you're going to get your motor planning with your mouth, where some kids will have that, and or with written. The parietal lobes do all the interpreting from our vision and hearing. This area coordinates all our visual and auditory perceptions, and once the parts of our vision and hearing are interpreted, the part of the parietal lobes called the motor cortex contacts the frontal lobes for final instructions, then tell the basal ganglia what messages to send to the body. When this area of the brain does not work efficiently, many takes that we take for granted don't work well. This area of the brain helps us feed ourselves independently. It also helps us bathe, dress, and move about our environment effectively. Additionally, I hit something wrong. Cancel. Additionally, if this area of the brain is not working properly, a person's handwriting will be a source of anguish, and the amygdala will try to override rational thoughts. Hang on. And send messages to the hippocampus that writing is evil. I like that, Cheri. And don't do it. Rationally, we know that it is false thought, but kids can't combat that, and they feel that at such a young age, since their frontal lobes are not finished growing. So that's where your executive functioning is going to come into play. So the last of the areas of the cortex are the chief executive officer of the brain. The part of the frontal lobes called the prefrontal cortex is home of the final decision-making organ of the brain and our executive functioning skills. The prefrontal cortex is essentially the last ascending sensory destination of a message from the body. It determines how the rest of the brain will respond if given the opportunity. If a person reacts to a situation by instinct, the prefrontal cortex never gets the message. Frontal lobes of elementary students are small and do not come to maturation until puberty. When you are learning a new task, it takes 20% more energy than after you have developed a neural pathway for the task. And last week we were talking about how, Paula, like when I tell my kids when we're doing cursive or when we're doing a writing, I like them to trace. And the reason is because I'm working on what I call a pathway. So in this case, if I've made that pathway, the next time they do it, that pathway gets deeper and deeper. So that's why I do a lot of tracing if my kids especially can't do it without, do it automatically and they can't do it by themselves. Because if it takes that pathway, it takes so much effort to get that pathway deeper or deepened, then once they do it on their own, that pathway is deep enough, if you use that language, and they should be able to get that more I love my word automaticity. They should be able to do that because that pathway has already been incorporated with their eyes, hand, and movement. So they should be able to get that no problem. That's when those kids don't have that, is they don't know. And because even if I've had to go behind them and like go, this is how it feels. Close your eyes. Do you feel this movement? Because they need to get that pathway instilled in themselves. So to complete the task, to make it automatic, if you don't continue to use it, the brain will override that pathway and create a new pathway to automate something else. That's just how they say you use it or you lose it. And this is the area of the brain responsible for executive functioning skills. And so executive functioning skills, there's a list: goal-directed persistence, metacognition, one of Cheri's favorites, flexibility, time management, organization, planning and prioritization, task initiation, sustained attention, emotional control, working memory, and inhibition of impulses. You name it, all our kids have these problems. And you can see where, if you get to that point in the brain system and the kids have issues there, everything that was there backs up. So that's where a lot of our kids have that executive functioning issue. And so all of that stuff backed up because of that. It's like we have to deal with a lot of executive functioning because the stuff's not coming through to that end product. And
So I'm going to add here.
I know you wanted to jump in there.
That this is actually a developmental list starting at the
Right.
bottom. Inhibition
Yep.
of pulses happens first. Then we can layer on the executive function of working memory. Then we layer on emotional control. Then we layer on sustained attention. And you think, oh my gosh, but yet a 2-year-old or 3-year-old is sitting in there playing with a game for so long and they can't even hear you when you're calling their name. But think about how quickly that little group comes together and gets developed. It's not until puberty that the executive functions of planning, organization, and time management even start to become part of the executive function. So why do you think elementary kids have so much trouble with planning, organization, and time management? Their brains aren't really developed to the point where those executive functions are even kicking in yet. And then flexibility, metacognition, and directed persistence. they can develop as late as age 35. So think about when we're thinking about executive functions and thinking about the average kid, yes, they build on one another and they're all coming together slowly, but we got kids with neurodiversity. Yeah, those neural pathways are not working.
And then you have the teacher who's there. Come on, you're going too slow. Come on, you need to move faster. And the kid can't. Okay, so you've got the inhibition of impulses. You've got the kid with ADHD who hears like listen, I'm going to tell you, I hear buzzing lights because I have to say I must have adult ADHD because I need to have all the balls in the air. But if I hear buzzing lights or if I hear kids talking over there, I'm not going to be able to be in inhibition of those sounds. If I can't do it, how are those little guys doing it? So it's really difficult to expect that of a kid in a classroom, especially the large classrooms that we have lately. So you're talking about trying to get all this going. And that's Sherry's got her stuff going with her teachers. And I think this is where the teachers really need to have some, if I call it sympathy for the kids, or have some cognizance of where these kids are and how to meet them where they are. And this is an important part because if you think about how we've traveled all the way from the brainstem to the frontal lobes, and this is where all this information has to get to. And if anything through that pathway is blocked or has some difficulty or defect, we're going to have a problem getting there. And if we're servicing these kids, then there's obviously something there. So if we can't get to that endpoint, these teachers are going to have it worse than we are because we only have them, say, for 30 minutes or 45 minutes in Beth's case. And we're going to end up trying to service them as quickly as we can. And these teachers have them all day. So I think it's a very important thing to explain to these teachers that, look, this is where show them executive functioning and show them that it's very important to work within the kids' means and not try to expect so much from them at this point. And I think Beth, especially with your teachers, explaining a little bit more to them and saying, hey, this is where they are. And I think it's just, if we're not getting taught this in our schooling, like Cheri said about certain things in the brain, these teachers are getting snippets when it comes to executive functioning, and they're not getting taught enough as to where a child lays in developmental milestones when it comes to this either. They're expecting them to complete like 30 minutes of work in 15 minutes because they want them to work faster. They're not going to make it that far, especially if they have any deficits. And they don't even need that much to be in a classroom of 30 kids. And Beth has the option of a small classroom, but still, if they're not getting enough attention, they're still going to have a little bit of trouble. Any questions up to this point? Are we good? All right, I know it's been fast. The right and left hemispheres, they're distinct divide. I had a child, believe it or not, who didn't have the corpus callosum, which is the center point in the middle of his brain. And he shouldn't have been able to do some of the things he was doing and crossing midline and doing stuff like that. But remarkably, because of the way the brain is, he was able, the connections were made, even though he didn't have the really center point in the middle of his brain, and he was remarkable. So sometimes you come across these kids and they can do certain things that you never would have expected. If you know anything about crossing midline and things like that, what happens on the left side of the body is stored on the right hemisphere, and what happens on the right side of the body is stored in the left hemisphere. And research has noted that the left side of the brain is more analytical and logical, and the right side of the brain is creative and imaginative. Emergent readers and early writers use much of the students' cortexes as they master these tasks. Some students have difficulty making the shift in neural development. These difficulties could be demonstrated by zoning out and daydreaming or singing or humming to themselves. A special portion of the brainstem or cerebellum refines your movements and eliminates the potential for jerkiness. The limbic system, controls your fear responses. However, your cortex can regain control over these portions of the brain by training yourself to respond differently. The cognitive portions of your brain analyze the sensory input and give the body feedback through the motor response. These cognitive portions include the occipital, parietal, temporal, and frontal lobes. After decisions are made and the brain messages travel along sensory pathways to the body. We are going to talk about what OTs love the most, proprioception. We've done the brain. Now we are going to talk about proprioception, vestibular, kinesthetic, the senses that come from the brain. Now, Paula, this is very OT-ish, but it may give you some feedback into what the OTs are looking for, but also in your kids, it may also be some ways that you can position them to get them in optimal, if they need some pressure, you can, when I worked at the Eris Clinic in California, I worked with a speech person, or you can work with other interdisciplinary staff. But if I had a student and they needed to work on speech, we put them on this jumpy cage. And so they were doing speech and I was doing OT at the same time. So we were stimulating them and they were doing speech and technically OT. But because you were stimulating them, say proprioceptively, they were able to get what they needed, and then the output became speech. Think about that, even though we're doing it, which I call it OT-ish, but think about ways that you could put your students in order to get optimal positioning or performance, that you could get what you need from them as well. Proprioception is the pushing the joint together that makes it compress. When it is released, it stretches. This cycle of compression and release is called proprioception. It is the sense of deep pressure inside the joint that keeps it stable so your muscles and bones can work together. Your body interprets where it is in space on the neural feedback provided by the compression of the joint. I did a brushing program with one of my students, and every time you finish the brushing program, you would go and you would push in on the joints. Between your joints, every joint, there's synovial fluid and the nerve endings. And what you're doing is you're giving information, and any of that information that when you're pushing and giving the feedback at the joints, that goes into your brain. So they would also know, if as I go further, where their body was in space, but they were also getting that feedback and that push. One of my kids particularly liked his head being pushed, so he would get that sensation, and also his shoulders. So that is also a calming effect to their body when it comes to that sensory stimulation stuff. Cheri, do you want to jump in at all?
When I try to teach teachers about proprioception, I use the idea of a spring. You know, like the coil spring see in the back of a car. So that's the symbol that I use to describe proprioception, if that helps you make a relationship to it. I also stuck a graphic of the executive functions in the chat.
Oh, excellent.
And the colors are based on developmental. So blue is the first 5 years of life. The next age of kindergarten through 5th grade is purple. Into puberty, and then beyond puberty is green, and then goal-directed persistence is really a mature adult.
So vestibular, and this is where I was talking about my student jumping as well, and you could put them on a rocking board or different positions, has more of a neurological.
Before I go on
Go ahead.
mute, think about a tumbleweed.
Oh, yeah,
The movie,
yep.
The tumbleweed.
She likes to put those pictures. So which makes it more complicated. A simple explanation to the vestibular system is that it tells the body how fast and in what direction your head is moving. It uses feedback from the proprioceptive system in the joints, your vision, and your head and neck movements to tell you where you are according to the environment. The 3 main vestibular reflexes are listed in the table, called hidden sensory pathways: vestibular ocular reflex, vestibular spinal reflex, and vestibular cochlea. Am I saying this right? Colic reflex. In an intact vestibular system helps students copy from the board if the system is working efficiently. They could be dizzy or lightheaded when copying from a board because you got to go up and down like this. That will be a sign that a kid can't. Some kids will really freak out on that. They could have difficulty sitting at their desks. You'll see those slouchy kids. Or they could have difficulty playing outside on playground equipment. Those kids who can't climb, or if they've climbed up, they can't climb down. I've seen students who can't climb down, walk downstairs. And if they do, they have to hold on aggressively to the railing and have to mark time, which means go step by step. And even then, it's pretty horrifying for them to go down a set of stairs. Vestibular is something that I do a lot of. I've even had kids on a vestibular board fishing. Now, Paula, a lot of this stuff, if say somebody comes to you and they say, oh, they have some sensory issues, doing 5 minutes of any of the activities, sensory activities, and then sitting down and working with them would be something you could do or even incorporate within them, because you'll find that there's a big difference if you do that as well.
That's great.
Did you want to say something? Go ahead.
No, I was going to ask, I'm assuming does it develop as you're working with them? Does their vestibular system get stronger?
It could, if depending upon how severe it is.
Okay.
Some kids have such a need that you may not feed it enough. They may not be able to get regulated. It depends on how much it's like food. All these systems are like lacking enough nutrition. I'm giving it to you in that respect.
Right.
So their system, like I don't know if everybody has something that they like. If you happen to go to an amusement park and you love spinny things, picture that. If you're a person who likes to be in the jumpy thing, you know what I'm saying? Think about a kid that you know or you have. If your system's regulated, then you tolerate so much. But you also could be somebody that's overstimulated, that if you went into any of those things, you'd get sick and throw up. So think about that. This is where we are with these stimulatory things. So if your vestibular system is overreactive, you could get sick on these things. But if you're underreactive, like I could spin a kid around on a chair and they'll never get sick and they'll never have a problem. But 2 spins on one kid and they're on the floor. Right. You know what I'm saying? There's a regulatory kind of issue with this.
Sure.
Will a kid, it depends on their maturation too, is if their system will maturate and this will regulate. Go ahead, Beth.
Oh, no, sorry. Somebody just walked out trying to meet my dog.
Oh, no, go ahead. It depends on the kinds of kids that you get, how this works out. So kinesthesia is the feedback that tells you how we should move. It's conscious awareness of your joints in space or where your body is in relation to the environment. So if you closed your eyes, your arms are out beside you or above your head, so you know where you are in space. And if you walked from point A to point B in the dark, you know where there's furniture, you can get yourself from one point to the next. Stereognosis is putting your hand in your pocket and being able to pull out your lipstick versus the coins in your pocket. You can go and you can tell, or doing those, okay, what have I got in the mystery box? And the kids have to feel. Sometimes they need, if you think about it, sometimes a kid with one hand can do it, but sometimes they need both hands because they have to get both sides of your brain. Now, I tell my kids this all the time. When they're like this and they're writing, I say to them, you're only using half your brain. And they don't realize that as soon as they put both hands down in midline to one hand holds the paper and the other hand is writing, you're activating both sides of your brain. If they only use one side of their brain, they're only activating that half. And sometimes that only half is not going to give them the whole use. You know what I'm saying? If you think about it, they're not using their whole brain. So I'll even say to them, you're only using half your brain. Put your hand down and stabilize your paper, because then it brings both parts to the midline. Even if it were unscrewing nuts and bolts, like some kids are like, oh, I'm fancy, I can do it with one hand. Try it with 2 hands, and now you're activating your whole brain. So I do that with my kids a lot. Is I try to them, even if it's whatever it is, putting pegs in a pegboard, stabilize with one hand and use the other hand, because you're activating the whole brain. That's just if my kids were doing it, my pet peeve is don't put your hand on your chin, use your whole brain. Is the ability to know symbols. You play this game is, I'm going to write a symbol on your back, tell me what it is. Some kids they just don't have it. They can't even pick it up. They do it on the back of your hand as well. But that's knowing what shape I wrote. And that combines the vestibular, the kinesthetic feedback to tell your brain what to do next. Whoops, sorry, I went too far. So then Cheri's got this word called CAPS. There are 4 core requirements for controlled motor response to function well. Okay, so think of the word CAPS. Controlled postural control. Postural control is defined as the act of maintaining, achieving, or restoring a state of balance during any posture or activity. Stability within the neuromuscular system is the ability to control the center of mass relative to the base of support. Motor control is how the neuromuscular system functions to activate and coordinate the muscles and limbs involved in the performance of motor skills. Both new skills and those already acquired need to have the motor control. Eye-hand coordination is the ability of the vision system to coordinate the information received through the eyes to control, guide, and direct the hands in the accomplishment, of a given task. Okay, so that's where the C in CAPS comes from, control. Accuracy and precision. Accuracy refers to how close the precision refers to how close. Oh, I was bad on that. How close together a group of measurements are to each other. In your book, there is an example where she has a circle. Accurate, not precise, accurate and precise, precise, not accurate. So there are ways to be both. Precision has nothing to do with the true or accepted value of measurement. So it is quite possible to be very precise and totally inaccurate. You can be accurate and not precise. You can be accurate and precise, which is the total target, and precise but not accurate. She's very picky on those. The same thing goes for writing your letters. You can be accurate and precise, getting it exactly where you want it. You can be precise only, so you have the right shape, but you can be precise and not accurate, putting them on the writing line. Then we have speed and fluency. Speed refers to how fast an object is moving over time. Another way of describing motor speed is the rate and quality by which information is processed. Okay, any questions on those? All right, visual acuity is the ability to perceive, test, to perceive test of a certain size at a certain distance. I don't know what I wrote there. A lack of visual acuity can be corrected to 20/20 vision with glasses. Tasks of a certain size, sorry, not tests. And then oculomotor function is the motor output of the eyes. We call it oculomotor function. Our eyes work best together when the muscles attached to each eye work simultaneously. Each eye, I love this part because Cheri really loves this, has 6 muscles that permit it to move left, up, down, and diagonally. They are supposed to work together in what is also called eye teaming. When the eyes are not in alignment with one another, the condition is called strabismus. When a lazy eye is subtle, it can result in double vision. There's an activity that Cheri does is we have a board and then we have the kids do up, down, across, side to side, and diagonal as well. Not only do you have issues with the kid writing, but you have the issues with the kid visually. You can work on those tasks as well so that they work on their eye function if they need to do some activities. Then convergence, you all guys know that when I have my kids look at a pencil and then when it gets closer to your nose and it's anything that comes in close, that's convergence. Your eyes come in to your nose and look in closely. When it's divergence, your eyes shift away 10 or more feet from you. Your eyes move back into center. The ability to look back and forth from the paper to the board quickly, or even left to top to bottom of the paper, is visual scanning. Now, I have a lot of kids who really, if you need to use your finger, you're really having problems with visual scanning. I give a tool sometimes for the kids to use a tool for visual scanning. And nystagmus is the overflow of movements that the eye does when you spin. And this is the part about that. And it is possible to have a student with both convergence and divergence issues plus nystagmus. Now, that would also mean that I check for that. And if my kids have any issues with, and Miss Jamie does that, and I took that course. It's an online kind of course you can take with her. Miss Jamie does that. It was really interesting to see, and there's a box string that you can do exercises with. You can get that string on Amazon and do some activities with your kids if you find that they have OTs now, believe it or not, are doing a lot more. There was an OT that did it with her that are doing a lot more visual exercises with their students. But I always recommend, and parents don't necessarily, they'll bring them to, they'll bring them to Walgreens or whatever, not Walgreens, but yeah, Walmart or wherever, just to get their eyes checked. If you're suspecting a really bad visual issue, they need a developmental or a pediatric optometrist to check their eyes, because that's something that's going to be impactful. I recently, a few of my kids in first grade just got their glasses, and it's definitely important to have, if they need them, to have them. It makes a big difference in what they're seeing, and if they need them for scanning, especially. Cheri, you want to jump in?
Mm-hmm. I stuck an image in the chat. Hopefully it opens up for you. Maybe it won't. Let me see if I can do it again. Can you see what it is? It's a bunch of letters with arrows.
It opened for me when I downloaded it.
It did open, so you can see the letters on it?
Yep.
Okay. So what I do with that exercise is I have the kids start at the letter R. And then, so I'll put it up on the big board and like the smart board in front of them so that it's really big, they're far away rather than small on a little piece of paper. And so I have them start and I have them look at the R. Then we go up to the A, back to the R. O, R, E, R, O, R, N, R, S, R, T, R, U, R. And we keep going around. And so what you're doing is you're working all of the muscles inside the eye, trying to get them to team them together. So that's a quick exercise that you can do. Now, let me pause here and think about the dyslexia tutor time that you have with your students. This could be that the kids are starting to get a little bit with your lesson for the day. You could stand them up, have them do a couple jumping jacks. This exercise, you could put it up and they could do this exercise and then you resume your activity. Jumping jacks are one thing. There are a bunch of other things that you can do, but that is in the dysgraphia course at the very end. That's the bonus module, is all the things that you can do. I don't know, Beth, if you took that or not. I can't remember what we talked about last year when I was down there. That is part of the dysgraphia method course at the very end.
Great, thank you.
You're welcome.
All right, we're just going to jump to memories. All right, so we're going to finish off with memories, and then I wanted to show the sensory motor pathway, and it's in the book, but I wanted to edit that a little, and I'm going to work on a chart for that. But I want to finish off with memories, decoding memories. The hippocampus holds the memory of the sensation for about 24 hours. The process of reaction to the sensation becomes a memory, is divided to 3 basic stages. First is the fraction of a second of the actual sensation occurrence. Your hippocampus also holds that moment for a fraction of a second. The stage 1, sensory memory, stage 2, working or short-term memory, and stage 3, conversions to long-term memory. Okay, so then it's decoding of your visual memory. Visualization is defined as the ability to mentally manipulate the visual image. So where am I? Visual memory is the ability of the child to recognize and recall visually presented information. Your sensory memory activates your prefrontal cortex. So good visual memory recall requires activation of both hemispheres of the prefrontal cortex. This procedure is called compensatory activation. Memory is the encoding, storage, and retrieval of learned information. And learning is the process by which new information is acquired by the nervous system and is observable through changes in behavior. Declarative memory is the storage and retrieval of material that is available to consciousness and can in principle be expressed by language. Procedural memory is defined as memories that involve skill and associations that are acquired and retrieved at the unconscious level. And elaborate encoding is connecting new information to old information. Active recall is the ability to use your notes without looking at them. And then spaced repetition uses the idea of studying 1 hour per day on a specific section of learned material. And then once that learned material is recalled, it can be continued to review the material over time. The material is integrated with other material from other parts. And then because it's there, it's spaced out. Muscle memory is a synonym to motor learning. It also is used to describe the building of muscle mass. And then movement connection, it creates motivation on the screen through movement. Visual and auditory stimuli mixed together to create this new world of education. So that is the whole first section, the second section of the book. Now, the one thing I wanted to share with you was, let me go to my, where am I? I wanted to go to, yeah, where is, let me share. All right, I'm not getting where I want to go. New share.
If somebody did like me putting,
Whiteboard, launch meeting. That's the book study. That's the download. Sherry, I'm trying to get to the book online. Why am I not going there?
Just
Maybe I
go
need
into
to.
labs. Go to
Huh?
courses. It's under the courses section.
All right. I go to new share. Screen, whiteboard.
You don't want the
Downloads.
no.
I know I saved it.
I'm finishing something. I'll be right with you.
Okay.
And courses.
All right. Let me stop sharing and maybe if I go back to share again, I can get it.
Yeah,
Share
that's what.
screen.
Yeah, yeah. It was probably
And
because you were sharing the other thing.
brain, book study. That's launch meeting. That's my whiteboard. All right, let me go back in again. Ugh. What if I do this? I don't know.
Well, stop sharing and I'll share
All right, stop share.
because I have it up.
Okay, can you go to the sensory motor pathway, please?
What page?
It is page. Yeah, I'm gonna go back. Right, it is page.
66.
Let me see.
Nope, not in here. It's after that though.
I just had it too. I hate it because I had it.
That one?
Yes. All right. Let's just bring it a little bit bigger. Can I control it? No.
I can.
All right, just bring it. All right,
Ooh.
and then center it. All right. All right, so this is where I'm going to make another one of these for you guys, but I was trying to do it earlier, but I didn't do it. Sherry, I really love this the diagram that Sherry made up about how the sensory motor pathway connects. And if you see the first one, it says stimulus from the environment. Now, I have another one. It does say stimulus from the environment, but this is decoding the sensory pathway. So that's the first step. Step 2, she's got neurological reactions to the sensory system. So that's step 2. Wait a minute. Sorry, I gotta find mine, other one. That was my first one. It would help if I had half a brain today. And I was prepared, girls. What is my other one? And Sherry knows because I was on the other thing too. Oh, wait a minute. Okay, stimulus from the environment. Then number 2, if you consider number 2, the neurological reaction in the central nervous system, that also is the brainstem cerebellum. Okay, and the limbic system, the amygdala, hippocampus, and the thalamus. So when that comes around, going to number 3 is maintenance of that change or the synthesis. Number 3. So how it goes into number 3. So then you have the output of that change, motor, behavioral, or information. But that goes into the cortices, the occipital, parietal, the temporal, and the frontal lobes. So that's where, as you see it going around. And then it goes into the output of that change, and then it goes up back into the limbic system and the basal ganglia. So it's going around like that. So it's going like this. So what it was connecting was I was putting the brain pieces that it was connecting to as it was forming around. She gave that on another time that we were meeting together, and I liked the fact that it had like the brain pieces along with that, so that you could see what brain areas were being implemented at that point in time. It was nice to have this along with that. So I'm going to try to combine those two together. But the brain-body connections with the spinal cord, the shoulder, the body, and the fingers, and then that connects to the handwriting, the motor response that you get. In that whole circle, it takes a lot to get that motor output. And really, and Paula, along the way, we're seeing that there's places along this pathway that any dysfunction and any glitch in this pathway, I guess we're lucky we see the kids, we have kids that are functioning as well as they are, when we have the percentage that could go off track in any one of these spots. But when we think back, where in this loop could we address anything? We have possibilities. If we've worked on one area, maybe that's not the area we need to work on. Let's find another spot that we need to address. I now see it every time I go back in it, more and more places, like we talked about today, the basal ganglia. Well, maybe we need to address things. What is going to be working on? What could we do to address those areas? What could we do to address something in the frontal cortex? Let's research. If for nothing else, I have not seen, and Sherry knows I'm a researchaholic, I have not seen a lot of research out there that actually addresses the places that I think it does more as the end product, like why kids aren't writing, as opposed to what in the brain prevents them from writing. I don't see a lot in what prevents the preventative as opposed to the output. Like, how do I fix the output? I see more of that than I do see the problems in the brain. Sherry. I know you have something to, no, nothing to say. Anybody have a comment or anything? Beth, anything in your travels? But do you see what I'm saying? That there needs to be more out there. There's not enough.
That I do agree on. We tend to look at primarily the motor output that's observable and not look at the deepest root cause as opposed to the lowest foundational skill. I do agree with that. Yeah. But I also think in my training, we weren't really taught, in my schooling, we weren't really taught to look that deep, but to look at your foundational skills as a hierarchy and try to figure out where on that hierarchy you need to start, and then to prevent your splinter skills and keep moving forward. But, I don't think a lot of the brain information and ways to strengthen the neural pathways was really ever talked about. And a lot of the continuing ed doesn't speak to that realm either. Right. It speaks more to the realm of how to activate activities, to activate it, and to get the coordination and the communication between the two hemispheres stronger.
like treating the symptoms and not the problem.
Yeah, yeah.
Yeah.
And I think that's where the understanding of, but if you, it was funny because I had a lot of kids who got put on ADHD meds and quote unquote, the problem got fixed, because once that got fixed, then it's like it snowballed and the rest of the stuff got fixed. What parents don't get is if the underlying product is not fixed, then that other part of it doesn't change. And doing one part does not change the rest of it. And I think that's important. I just wanted to share with you because it got shared with me, this book from, and I'm going to look through it even more. This is one of John Lee's favorite books, but in here, it's Number Sense and Number Nonsense. This is John Lee's book. And as I was flipping through it last night, I didn't have time, but there are a lot of points in here. And Paula, this may be stuff it had just, I opened the page, reading disability and mathematics. There's a lot of things in here. Can spatial skills be learned? There's a lot of stuff in here. I got it. And I really, with everything I keep getting, executive functions, there's a lot of stuff in this book that don't just mean numbers. And this I can see, but it has a lot of, let me flip to a page that I was looking at yesterday. It had
Who's
the brain.
author of that book? That's not John Lee's book. Who's the author?
No, I'm not saying it's John Lee's book. John Lee's favorite, one of John Lee's favorite books.
No, Number Sense and what? Put it up
It's
again.
Nancy Krasa and Sarah. Sorry, I gotta get it so you can see it. Wait, I'm out of focus. There it is.
Number Sense and Nonsense.
Nonsense. This isn't John Lee's book, but John Lee's favorite. It had a brain and it said the view of the brain's left hemisphere showing the quantity sensitive interparietal something, and I can't even say it, something, and surrounding visual spatial region, as well as the areas activated by incoming visual perceptions and by manual tasks. These functions also reside in the right hemisphere, but it had brain things. Sorry, it's not going to show. There it is. It had brain stuff. I was flipping through it because I haven't had a chance to do it, but it had a lot, the neurology of spatial, mechanical, and geometric reasoning. Talk about stuff that had, it talks about math and reading, but how the brain reads numerals. So I haven't had a chance, but it sounded like there was lots of stuff in there to talk about the brain too. I want to see if I put them here and I have the two articles, the two things here. There's John Lee's book.
And then here is John Lee's book, Making Math in Ears. Beth, I think there's several copies at the school.
Yeah, I did get one. Oh,
Now you did mute. You were okay before.
okay, sorry. I looked up and it said mute on me. I did get one of those copies, but I haven't read through the whole thing. I've skimmed it, but I haven't read through the whole thing.
Yeah.
You'll appreciate what's coming up next, Math Disconnected, when we finally get that one published.
Oh, yay. I'm excited.
So, Paula, just an FYI, I spoke at Beth's school last summer. Around the same time. It was about a year ago, wasn't it?
It was, yes, ma'am.
I want to give you guys my stuff. Sherry, how do I share my Word docs and the other things that I have?
You'll have to go into wherever you have the file saved in your Microsoft tree.
Yeah.
And click on it and drag it over.
Okay, I have them down here.
You're gonna have to have it closed to do
I have to
that.
close them. Okay, so close this one.
The thing I would advise you to do is save it as a PDF into your downloads, and then look in your downloads and send the PDF over instead of the Word doc.
Can I save them as a PDF?
Yep. In Microsoft you can. And that's what you were using.
All right, so here they are.
As we interlace John Lee into the conversation, number sense is one of the core foundational skills that students need to make the relationship to mathematics, but visual perceptually, if they can't understand what they're looking at, it's going to be like the same thing as a kid with dyslexia, where they can't distinguish the B from the D, or the P from the Q, the 2 from the 5 are typical ones. So there's other ones, but if they can't really make that distinction as to what the number is, that's part of the beginning parts of the visual perception, but understanding the concepts and how numbers relate to one another is another part of it. And one of the things that's funny that we don't even think about is the alphabet itself is like a number line. And one of the things that I've learned from John Lee is that the number line is the most complex and abstract concepts within mathematics. And when they put it to the song, they meant elemento as one kind of that just totally messes up the whole number line concept, because they made it have that sound. So it's frustrating from the kids. But have you ever, this is one thing that you can do, and this relates back to the number sense, have you ever started at the letter G and then had the kid go from the letter G and move forward?
Yes. Yeah.
How many of them can't do that?
A bunch of them.
Yeah. How about start at the letter G and go back to where can't do that either?
Yeah,
But getting kids to understand that they don't have to start at the beginning
right.
of the alphabet
Yep.
is a connection to number sense.
Yeah, we do a lot at the beginning of just that. Your left hand is your beforehand. It's A through M, and then N through Z is your right hand, is your afterhand. And it's that same kind of number sense of thinking about where letters are in the alphabet. And then usually towards the end of second grade, I start to introduce alphabetizing and reasons why we do that and how you think about it. And that kind of helps also with that number sense feeling of where things are located.
If you think about each letter, like it would be like a tick on the number line, it also can introduce distance. How far away is N from Z? How
Right.
far away is
Yep.
P from L? And make sure that you're going in both directions
Yep.
so that they get an idea of hopping backwards.
Yep.
Have you ever seen this before? Done anything like this before? Oh man, I think you may have done that in math class.
Yeah, that's a great, because those are all things that I do, but I've never thought about how it connects to numbers, and thinking like that's an easy thing to add in just to make that connection and help that brain say, oh yeah, I can do that both ways. And it's the similarities.
Yeah.
Yeah.
Beth, what are your comments? I can see I can see them working.
They are working. I tend to pull in more things like graphing than number lines, but it would be an easy switch for us because I tend to do a lot of the alphabet things and number things with what we call ladder drills, which is that in athletics, but that can easily be converted into a number line without numbers, but then they can either sort or plot their cards of numbers or their cards of letters and where they think that is. But I also can see that really connecting into concept of time. It's real interesting how none of my kids have a concept of time. I'm like, how long do you think it's going to take you to run down the hallway? And they're like, a minute. I'm like, okay,
Yeah.
it's
I'm going to
seconds.
I'm going to share a technique. This is called paper folding. Will be the first week in September will be the episode where I really where I'm going to lay this out in the podcast. So you have a piece of paper. It's 11 inches long because you've cut it vertically. Okay. And this is where the OT thing really comes in with paper folding. And I'm relating this back to distance and something that we can do in here. And we're going to run out of time soon, but if you want to touch the ends together, we're not using any mathematical terms. Touch the ends together and push down to the middle and squeeze. Now, what John Lee and I have talked about from an OT standpoint is switching it up to cardstock or other weight paper will change the proprioception pieces for the students. Okay. Now, how many pieces do you think I have in? How many parts do I have? Very good. Let's open it up and we'll find 1 part, 2 part. I'm going to close it again. I'm going to do this little, kind of on the fast side here because we're not good on time yet. All right, we're going to fold it again. Now, how many parts do we have?
4.
4. Let's open it up and find out. 1 part, 2 part, 3 part, 4 part. We're going to fold it again. Beth's turn. How many parts do we have?
6.
6?
Yeah.
Paula, how many parts do we have?
8. Wait, no, we created 4 more.
6 is the best. 6 is the best wrong answer. So John Lee has also done a lot of research in what kids respond. And one of the books I keep telling her she has to write is the best wrong answer. So we have
what a great
1
title.
part, 2 part, 8. Okay. So one of the things that kids get frustrated on is when you put the number in between, they think that's where the tick is actually here. So John Lee always has you write directly on the tick. Okay. So we switch that up. And you could put your ticks as LMN or whatever. But let's flip this back to time real quick. What would be the middle of time? So we're looking at what would be the bottom number. Let's ignore the fact that I put those on there. Okay.
6
So-
o'clock.
6. What's another way of saying it?
Half hour.
30.
Yeah,
Oh,
so I went
30.
to 30 minutes.
Okay. So 6 or 30 are the 2 numbers that you see. So if this is 0 and this is 6, this is 0 and this is 12 and 60. So we actually now have 2 timelines, two number lines, but they don't realize it. So we have 0 to 12 with the 6. Then we have 0 to 60. Watch what happens when you make a circle out of it. They take all those little ticks that you've been working with them on, and they have a circle.
Mm-hmm.
Did you get it? Do you get it, Beth?
Mm-hmm.
Okay. So making rectangles is one of the first things she talks about. And this is what she talks. And then this is a way of applying the making rectangles is using that. So having them folding paper, you can relate that to your letters and numbers. So one of the things also that you could do with that, Paula, with the words is on the ticks, put the words or the letters to the word, and then they can then maybe count how many letters there are in the word and stuff like that. So just a quick thing of how to adapt paper folding to utilize words. It looks like we've got a lot of things to download.
Okay, so I gave you the 2 this week's is the brain. Last week was book study 1. I gave you some articles on retained reflexes. And then I did the class at Integrated Learning Strategies. And there's also Harkle. And so there's a few things out there that you can look up stuff on retained reflexes. Those were just some articles that I happened to find that you can just download. There's so much out there on it. And then there's some good stuff.
So HARCLA tends to primarily look at the infant development, the child development and how they're supposed to integrate. And the other one that you said,
Integrated.
Yes, she tends to look more at retained reflexes in the older child. So
Yes,
you can look at the two informations differently. And then,
Yeah, I did that one.
yeah, I like her. I'm glad you've done that one. I've read all of her books. I'd like to go and do that one. And then if
Yeah.
you just need, like,
It wasn't that, I don't know why it wasn't that expensive. Kim Wiggins did one through another age. There was I don't know if they did it last year. They did a summer, like a whole thing. You could do a whole summer thing for $300. So I paid $300 and you were allowed access to all their coursework for $300 or something like that. They may have done it again this year, which was, I'm telling you, like soup to nuts. You were able to get all their webinars. And I did that. And Kim Wiggins, an OT, had tons of them. But it was one of the webinar people have, maybe if you look up Kim, and she probably is doing it through them again. But she did a ton of different, like she did stuff on different classroom-based things. And then that's why I gravitated towards her. She has a website as well. But she also did a retained reflexes, just a class. But there were other people there, but there were tons and tons of like coursework things. I couldn't even do enough, but I did $300 worth, believe me. And then, okay, save the chat. Well, yeah, so there are tons of stuff out there. But all I have to say is if you have anything, Paula too, if you have anything, say, oh, I have a question about this, save it. We'll start next week with questions that you might have. Say, oh, I have a kid, bring a kid forward and say, hey, I have a kid with this problem. What do you think? Because like last week, we may have gone on a tangent, but it was so well worth it. You know what I mean? It helped everybody out, and it may be something that we can all benefit from. Beth, yeah, I know there's so many out there. There are so many people with little bitty things and stuff for information. Some places have cards you can hang on to. Cheri can hook you up to her person that came in and did the reflex course there. That was wonderful. It was well worth it. Her person that did it. She did a two-parter and we really had a lot of information from that. She actually had her son did it with us, but there's so much to be had by doing this kind of information about brain picking and everything like that. I think it's well worth it. Any other questions, ladies?
no, I just
It's
looked
funny.
up Kim
Yeah.
Wiggins. I just looked her up. The only thing I was going to say is if you want more of the brain, how it's all connected in the brain and the neurological processes that go to it, Karen Pryor, who does hers out of PESI, is a great one on the reflexes, but it's more neurological based. So I do like her, but I'm going to look into this one because this one has a screen. So I like that. Oh, sorry, there goes my dog again.
Yeah, the integrated, she brings a student in and does all the things in front of you, which is really good. Whatchamacallit, I was gonna say something, but it's just, I know, Paula, it's really hard because it's not, but if you have anything that, like I say, if you have a little tidbit thing that you want to offer, please feel free, because we're definitely looking to address other areas as well. Even if it's student-based, because Cheri's got that side of the kids covered. She'll help you with classroom-based, student-based stuff with teachers.
Sounds
So,
great.
So
Okay.
before we end today, we are running out of time because this meeting will automatically cut off at
Yeah.
10:45. Paula, what was your key takeaway today?
My key takeaway is interoception. I wrote some notes about that, and the basal ganglia, because in all the stuff that I've done read and learned about the brain, the basal ganglia also is not mentioned in the dyslexia piece either. So it's really nice to like hear new information and keep learning. Yeah.
Perfect. I'll try to get some downloads from Kelly Marr
Yeah.
on interoception that are free for
That'd be nice.
next time.
Yeah,
So-
I have several kids that I'm like, you are just not reading it. Your body
Yeah.
is not reading it. So,
Yeah. So
yeah,
what's your
from today? So I really was looking at, in my brain, I was thinking, how can I take some of the activities that I currently do and flip them a little bit into more number sense and letter sense? Because I don't tend to tackle that. I tend to tackle more of the rote memory and how it connects. Why do we rote memory skip counting? Well, because you're actually multiplying, like making those connections for them. But sometimes that's a little more higher order. So I should probably back it down a little bit. You tend to think they have it when they don't, but they have great compensatory strategies. So anyway, my brain was clicking on how can I take some of what we do and just downgrade it a little bit and then build up on it while we're doing our cognitive motor stuff. So that's really where I was going.
Paula, do you guys do dibbles?
Mhm.
Okay, just checking, because that's the new thing for getting the dyslexia qualified
Yeah.
kids.
Yeah, it's just one of the many pieces that we use.
All right, because we just got the new one.
Yeah. So I got sad news this morning.
Oh no.
No.
Pennsylvania did not pass the bill that was on the table, was not passed signed by the governor to implement the dyslexia structured literacy in this year's school. So we are back to square one to get that bill through Congress for next year. So it's been a very long road, and Pennsylvania didn't do it. And I was very upset when I read that this morning.
That's frustrating.
There's a lot
Lots
of
of
work
hurdles.
and in Arkansas too. There's just a lot of work.
Mhm.
I don't know.
There's I will tell you this, there's 30 states that have already had things implemented, and I don't have the link right on me. I'll try to remember that for next week. Ohio has listed out all the recommended dyslexia programs and on their website. I have to go back through and see if I can get the email from my friend who lives in Ohio that shared it with me, but I'm not going to be able to do it before we get hung up on today. But if you do take some time, there's approved dyslexia or structured literacy, approved structured literacy programs in Ohio. You might be able to find it on your own. It's very interesting to see what's been approved and what is not approved, and some of the stuff that people are using. The person who I was talking to was actually sitting down with the state span for the state to lobby for her company's product to get implemented. And so I do want to circle back to her because it's been a few weeks, because I did talk to her at the end of May. So it's actually been like 6 weeks. But wondering if her program is, because she's the one that uses the puppets, and puppets add another dimension that is really powerful for students, especially the little ones.
Yes, I would be interested in hearing what they have. But
Wilson's one of these at the top, just so you
Yeah.
know. We're using Wilson. That's almost up at the top. And Take Flight is pretty much up there in Texas, and they're very similar.
yeah. I just as the OT that works, and I work in a school for children with dyslexia, but I also work in some charter schools. And I don't know if it's because my child is dyslexic, and he had this collective. We went through one thing, he was able to get that, and then we had to move to another little program. He was able to catch on that part, and then so I feel like as the OT, if I can bring in little parts of more than one of them's gonna make that connection for them and hit it where I understand the whole point of doing the Wilson over and over in their classroom. But I almost just feel like if I can find that something that connects for them, but my personal experience is limited. So I would be interested. Yes. And I love that. I'm not going to lie. I do love that because I have noticed, and I had one sweet little one, I was getting him to write the alphabet, and he goes, I just don't know how to write LMO. It's okay. Just try your best. Because it was during testing, and I just thought that was the sweetest, cutest little thing ever. But I thought, oh, there's a big disconnect. So anyway,
Send it down to the Alamo in Texas. Okay.
And that was for Elmo. It's like, okay.
Elmo,
Oh.
Elmo, the red guy. That's how I got his name. You
So
know?
what is the law that the states have?
It's under Every Child Succeeds from Obama.
Okay.
That's where the federal law started. We're going to be cut
Okay.
off. So each state had